Hello, math students. We are going to pick up today working again with our product of powers properties. We had a bunch of different rules that we all kind of threw together yesterday. So let's review those a little bit. And when I leave these answers as powers, that means I don't have to actually use a calculator and evaluate these yet. When we say product of powers, remember, powers means something with an exponent, and product means I'm multiplying. So I am multiplying things that have exponents. And when we have the same bases, in number one, we've got 2 as the base. So I've got 2 to the third, which really means 2 times 2 times 2. Then I've got another 2 to the third, which means 2 times 2 times 2. And then I've got a 2 squared, which is 2 times 2. I could write all those out if I wanted to, but we had a shortcut. We said if they're the same bases, we just have to add these exponents. So 3 plus 3 plus 2 would give me an exponent of 8. And again, we're not evaluating. I don't need to know what 2 to the 8th is equal to. I want you to be able to write this with an exponent. Number 2, same bases again. Remember what this means is that we're going to add those exponents. So instead of 3 squared and 3 squared, I would have 3 to the 4th power. If I have numbers and variables, so I've got 3 n to the 3rd and an n to the 4th. If you want to, you can put a 1 right there. So I'm still just going to multiply the 3 times the 1 gives me a 3. And then I'd figure out how many n's I have. I've got n to the 3rd and n to the 4th. That'll give me n to the 7. When we write these answers, we do want the numbers in front of the variables. That's just the standard way that everybody writes math answers. So in number 4, we would start by multiplying the 4 times the 3, that gives me a 12. And then I've got an n squared and an n to the 4th, that'll give me n to the 6th. So that is the product of powers, multiplying stuff with exponents. Power of powers is when I've got an exponent on another exponent. Number 8 doesn't really fit that, but that's okay. On this, when I have a power to a power, when they're both exponents on the same thing, power inside, power outside, that's when we multiply. So this base will stay the same, but my exponent will be a 12. Now, 4 to the 4th, I suppose we could look at this and say, oh, this is all to the 1st power. So when I multiply those exponents, I still just get 4 to the 4th. In number 9, I'm going to do this one the long way once. Remember, when I have a square for an exponent, that means I've got 2 of these things that are in parentheses. So that would mean I would have 3n squared times another 3n squared. And then the 3 times the 3 would be 9. I've got 2 n's here and 2 n's here. That's n to the 4th. If we didn't want to evaluate that and make it a 9, we could just distribute this exponent, right? So that would be 3 squared. And then we multiply those exponents, n to the 4th. Okay. Either one of those answers, I much prefer it when we actually figure it out, especially when it's a number as small as 3 squared. There's no reason to leave that as 3 squared. We would absolutely want to change that into a 9. For number 10, when we have this exponent on the outside, remember this is really distributing the exponent. So this 4 would go on to that 2. So I would have 2 to the 4th power. And then it would go on to that r, so I would have r to the 4th power. And then we could also figure out that 2 to the 4th is equal to 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. Today, we're not going to have just one kind of problem in one section and one kind of problem in another section. We're going to throw everything all together. So we need to practice what we do when. So we have to decide if we're going to add exponents, multiply exponents, or distribute exponents. And when we distribute, we are multiplying them. In number 13, we could certainly take that 2 on the outside and distribute it, or my preference is let's clean up this inside stuff. That would be 2 to the, I would add those exponents because they're the same bases, 2 to the 5th, and there's my exponent of 2 on the outside. Now, because it's a power to a power, I'm going to multiply that. That would be 2 to the 10th power. In number 14, I would have to take care of this part first. 2 to the 4th, 2 to the 4th would be really 2 to the 16th. So underneath here, I'm going to write down 2 squared from my first one, 2 to the 16th right there. And now they've got the same basis, so we would add those exponents to get 2 to the 18th. In number 15, again, I prefer to simplify stuff in the parentheses first if I can. If you wanted to, remember you can put a 1 right there. So I would have the 2 times 1 would give me a 2. I've got a v to the 4th and a v to the 3rd, so that would be v to the 7th. Same basis, we add the exponents. Now this is all to the 4th power. So this 4 would go on to here, so I'll have 2 to the 4th power. We just figured out what that was in the last slide. And then here we're going to multiply those, so that would be v to the 28th power. And 2 to the 4th power we figured out was also 16. In number 16, I would put a 1 right here. And if you wanted to, you could even put a 1 right here. But I'm not even starting with that m. I have to deal with the stuff with the parentheses. The 4 on the outside is going to have to distribute onto the 2 and onto that m to the 3rd. So I'm going to keep that 1m, and I'll even put a 1 for an exponent. 2 to the 4th power, I'll write that down, but again, we know that's 16. And this will be m to the 12th power. Power to a power, we multiply. Now, we said this is really 16 for this 2 to the 4th. So I would do 16 times 1 is 16 for my coefficients, my numbers out in front. Then I have 1m and 12 more m's. That's 13 m's. So in this first one, there aren't any parentheses. So it's not like I have to do anything in the inside of their first, so there's no concern that way. And since there's no parentheses, we don't have to worry about trying to multiply exponents. We are just going to look for the same bases. Now here's why this is a little bit more tricky. I've got x's and I've got y's. Anything with the same bases can go together, but if they don't match, they don't go together. So I would have my 3 that's going to stay on the outside, or in front, I should say. This first x is really x to the 1st. So when I put these together, same bases, I add those exponents, that gives me x to the 3rd. That y squared just kind of hangs on at the end. Numbers, and then when we do variables, we want to go alphabetical. So we would usually want the x's before the y's. Occasionally, you'll see some answers that are on here that have not alphabetical order, which I don't really like, but it's just kind of sometimes how worksheets write things out. For the second problem, again, no parentheses, but let's start putting things together. Like this 3 and this 3, I can multiply to make 9. Then looking at x's, I have an x to the 3rd, and I have another x to the 3rd. So I had 3 x's and 3 more x's, gives me x to the 6th. And now I'm going to look at the y's. I've got a y to the 4th and a y to the 2nd. So it's 6 of those so far, and then 3 more. So y to the 9th. Now I do have parentheses. I will have to distribute my exponent on the outside. The x's and the y's on the inside don't go together. I can't do anything here to simplify. So I would start by just distributing right away. So this x would now be to the 8th power. Remember, power to a power, we multiply. And this y would be to the 4th power. And for the last problem here, when I distribute this exponent, think about, I'll write it out as 3 squared, but think about what that really means. This is one of those where the variables are not in alphabetical order, which bothers me a little bit, but I can survive, I guess. This was just a y, or there was a 1 right there. When I multiply the 1 times the 2, I get a y squared. And then x to the, I would multiply those exponents, and 6. The only thing that's going to change here in my answer is that that 3 squared, we're going to change it into a 9. And again, I would much prefer to have this look like 9x to the 6th, y to the 2nd. But since they gave it to us with the y's first, I could understand leaving the y's first in the answer. All right, don't these look fun? These are going to be great. If you're feeling pretty confident right now, you may want to just pause the video, see if you can do all 4 of these problems, or do 1 or 2 of them, and then watch and see if you got them right. But we are really starting to throw a lot of stuff together. Still just those basic rules, though. So in the first one, this exponent is going to distribute. So I will have, even though I didn't write those 1s in there, that's really x to the 4th and y to the 4th. They both happen 4 times. This, I would say, is probably one of the most common mistakes that I see. People totally worry about the variables and totally forget about the coefficient. That is going to be 2 to the 2nd power. We'll change that into a 4, but that 2 gets squared. This x will be to the 8th power when we multiply those exponents, and y to the 6th power. Now, we said 2 to the 2nd power is 4, and we always want our coefficients, our numbers out in front. Looking at x's, I have an x to the 4th and an x to the 8th. Gives me x to the 12th. And then a y to the 4th and a y to the 6th gives me y to the 10th. In this problem, you could just automatically distribute the exponent on the outside. Personally, I would like to clean this up. I would like to simplify the stuff inside the parentheses if I can. And I can. So the 2 times the 2 would give me a 4. Then, again, I'm going to go alphabetically. X's, I just have these x's right here. So x squared. But for y's, I've got a y to the 3rd and a y to the 2nd gives me y to the 5th. This is all still to the 3rd power. And I just said in the last problem, a lot of people forget about the coefficient. This 3 for an exponent is going to go on to that 4. So that'll be 4 to the 3rd power. We actually memorized that one. That's 64. X to the multiplier exponents, 6, and y to the 15th. So when I write this as my final answer, I'm not going to leave that 4 to the 3rd. We would change that into a 64. You can see that they put the y first because in the problem they had the y's first. I like my answer better with the x's first. In this next problem, there's nothing to simplify inside the parentheses. There are parentheses, yes. Nothing that I can do to clean anything up though. So I'm going to have to take care of the exponent on the outside. And I would say I should put in a 1 right there. So I can see that's really a negative 1 times m to the 1st and n to the 2nd. This is going to be tricky for some people. Let me just rewrite that first part because I didn't do anything with this yet. I'm going to have now negative 1 to the 4th power. You might know what that is already, but I'm just going to write it down for a second. We'll come back to that. Then I'll have m to the 4th. And that's a really sorry about the bell. N to the 8th. Now, negative 1 to the 4th power, there are 4 negatives. That'll be a positive. And 1 to any power is 1, because 1 times 1 times 1 times 1, it doesn't matter how many 1s I have, that's just a 1. So in fact, this whole thing right here just changes into 1. And multiplying by 1 does nothing. So I can really just ignore that part. That just goes away. So I have my negative 2 as my coefficient. M's, I've got m to the 4th and m to the 4th. That's m to the 8th. For my n's, I've got an n to the third and an n to the eighth. That'll be n to the 11th. And in this last one, I've got parentheses inside parentheses. Super fun. So let's start with distributing this squared. Negative 2 squared, let me just write it like that, but negative 2 squared is going to be a positive 4. X squared and y to the 4th. X cubed, y to the 4th is still inside these big parentheses. Now, negative 2 squared, we just said, or I just said, that's really just equal to 4. Because of my limited space right here, I'm just going to change that into a 4 right there. That was negative 2 squared. Now, let's clean up what we have inside there. So I would have, I guess I could have kept that as a negative 2 squared right there. 4, and now I've got x's. I've got x squared, x cubed, x to the 5th. Y to the 4th, y to the 4th, that's y to the 8th when we add those exponents. And I'm still going to have that 4 on the outside. That's going to distribute. 4 to the 4th power should be, I believe, 256. Let me just write it as 4 to the 4th power right here. X to the 20th power, and y to the 32nd power. So 4 to the 4th, 256, x to the 20th, y to the 32nd. So today's worksheet is a riddle worksheet. It's the King's Son worksheet. Try these out. You may need some extra space. You might need to do these on a piece of paper instead of just on the riddle worksheet. The answer key is in Schoology, so check that. And when you're all done, make sure you take the learning check in Schoology and let me know if you need any help.